Hello everyone and welcome to my YouTube channel. In this video, I will be sharing a brief introduction on Nightshade. Nightshade is the NEAR Protocol's sharding design. Now, I know that all these words may seem like a little jargonish, but in this video, we'll try to explore what each of these terminologies mean. So let's get started with why protocols like NEAR. As we know that blockchains like Ethereum have been facing a lot of scalability issues as we see. There have been more and more new protocols in the market which are trying to solve the scalability issues and thereby provide a solution wherein real-time applications can be scaled and built to suit the real-time use cases. Some of the issues that we see as of today, like low throughput, high transaction fees in the form of gas fees, high prices, and high latency, make it unsuitable for blockchains like Ethereum to scale. Now let's focus on one problem, which is low throughput. Why does low throughput happen? Low throughput happens because all of the nodes in the blockchain network, such as Ethereum, need to validate / process all of the transactions that come into the network. Now, imagine the more number of nodes that join the network, the more time it would take for all of these nodes to work together to process the transaction. There have been a lot of solutions that have been proposed by developers to solve this particular issue. One of the solutions that NEAR Protocol is based on is also known as sharding. What is sharding? Sharding is the process of splitting a blockchain network into separate components, also known as shards, each of which act as an individual blockchain containing their own data separate from all other shards. There is intercommunication possible between the shards in order to ensure that the blocks that are being separately validated by these shards are also, the information is also passed on to the other shards. Now, what happens when you split a blockchain network into various shards? What happens is not all of the nodes are doing the work of processing every transaction. In fact, only specific nodes are required to perform to validate the transactions in a specific shard. So what ends up happening is that each node in the network does only a subset of the total work, thereby increasing the throughput drastically and helping scale. So let's visualize on what is sharding, right? As we all know, blockchain is nothing but a blockchain network contains of a set of nodes which process all these transactions and put them in the form of blocks, right? The transactions are clubbed together to create blocks. The blocks are connected to each other through cryptographic hashes, thereby creating a blockchain. What happens in sharding? A blockchain itself is split into several smaller blockchains. Each of them are known as shards. Each of these shards act similar to a blockchain wherein they contain their own data and validate and process a set of transactions that is given to that particular shard. Now, before we go into the specifics of Nightshade, we also need to understand another terminology associated with sharding, also known as beacon chain. Now, what happens in sharding? That there needs to be a set of validators that need to be assigned to each of the shards who can validate the transactions, right? Now, this particular operation of assigning these validators needs to be random in order to ensure that each of the shards are safe and secure, right? That the transactions that are being processed are not invalid transactions or malicious transactions. Because if we assign a set of standard validators to each of the shards, it is very easy for a malicious hacker to corrupt those validators and thereby corrupt that part of the chain which is coming from a particular shard. In order to avoid this, we have to create a kind of randomness, right, while assigning the validators. Now, who will do this? And as we all know, creating this randomness involves certain set of computation, as well as some computation is required to understand what are each of the shards doing, get frequent data from the shards, and in order to maintain a whole global view of the entire blockchain, right? This is where a beacon chain comes in. The randomness and the validator assignment require some computation, which is not associated with a particular shard. And therefore, we have a beacon chain, which is a separate blockchain, whose task is to perform the operations that are necessary for the maintenance of the entire network. That is, it works with individual shards and keeps all the information on a separate blockchain. There are two important pointers when it comes to talking about beacon chain. The two responsibilities of beacon chain. The first one is managing the validators and their stakes, right? And the second one is that who will be the block proposer for each shard, right? That will be chosen by the beacon chain. Now, beacon chain is a terminology that is primarily used in the Ethereum 2.0 context. This kind of chain is also known as a relay chain in Polkadot. Now, let's get into the actual protocol, right? So what is Nightshade? Like I said, Nightshade is the NEAR Protocol's sharding design. So what is unique about NEAR Protocol's sharding design, and how did it come into picture? Now, when we think about shards, imagine that you have multiple shards, right? You have more than thousands, 10,000s of shards just because you want to increase the scalability like crazy. Now, in order to maintain these shards and maintain for the maintenance of the network, your beacon chain will have to be programmed separately. So in this case, you will have to put efforts to create or program your beacon chain as well as your shards separately, right? You will have to put efforts to create the algorithms that that will be underlying in both of these infrastructures, right? And this would be a big problem in case we want to increase the number of shards, right? In order to scale our application more and more. This is where the Nightshade mechanism comes in. What happens in Nightshade? One of the unique differentiators in Nightshade is that even though at the underlying it follows the sharding system, the whole system, instead of split into a beacon versus a sharding chain, is considered as one blockchain, right? Instead of splitting the two entities, the whole system is considered as one blockchain, though there is sharding at the base of everything. Now let's see how this happens, right? What happens in Nightshade is that each block logically contains all the transactions for all the shards. So you have all these shards, right? Now, the transactions that are happening in these shards are kind of put together into the blocks, and the blocks then get added to create the bigger blockchain, right? So what happens in this case is that you're also ensuring scalability, because each participant of the network only maintains the state that is corresponding to the shard that they validate transactions for. Like I said, the main problem is that in Ethereum scalability is that each node is performing all the operations related to all the transactions. But in this case, each participant of the network will only maintain the state which is corresponding to the shard they have been allocated to. Now, another terminology here that would come into picture is a chunk. What is a chunk? In a list of all the transactions that are happening in the block, right, is split into physical chunks. That is, each of the chunks corresponds to a particular shard. So basically, a shard related transaction that goes into a particular block is known as a chunk. Let's visualize how Nightshade works under the hood, right? So like I said, imagine the entire blockchain is split into different shards, right? So as we said, it is based on sharding, which is the underlying base principle. Now, the chunks chunks are nothing but the transactions that are happening in these shards, and these chunks will then be put into the block, right? So one block consists of the different chunks which correspond to different shards. And all of these blocks are then connected to each other, as you can see, forming the blockchain. So this is one of the important things about Nightshade, is that though it follows the principle of sharding at the base of everything, it also ensures that the whole blockchain become there isn't too much maintenance with respect to the beacon chain, and the blocks themselves will hold the chunks that would refer to transactions from the different shards. Another important thing that I want to talk about Nightshade here is the consensus that is used by Nightshade. Nightshade uses the heaviest chain consensus. What happens in Nightshade is that when a block producer produces a block, they can collect signatures from other block producers and validators attesting to the previous block. Why is this important? Because we are using sharding over here. Whenever a block producer needs to kind of, produce a block, they need to ensure that there are people, or there are attesters who are attesting to the previous blocks as well, because it could be possible that some of the blocks in the other shards could be invalid, right? And they need to ensure that there are x percentage of people who are able to validate that the earlier, or rather attest that the earlier blocks were valid. Now, on top of the heaviest chain consensus, to do this, we use something called a finality gadget that uses the attestations to finalize the blocks. I will make another video about the finality gadget, but I just wanted to introduce the topic here. And the finality gadget on which the NEAR protocol is based on is currently known as Casper CBC. Casper CBC is a finality gadget based on which the current Nightshade paper is modeled on. I'll also show you the Nightshade paper here. As you can see, there is a white paper that is available, which is titled as NEAR Protocol Sharding Design. It has amazing information about all the sharding basics, as well as the protocol itself in depth, how the blocks are produced, what is the different types of sharding, what are the different drawbacks of several steps that are happening in the existing systems, and how NEAR protocol kind of aims to address these. So if you are interested to go much more in depth, I would recommend that paper. So yeah, that's it for today, and thank you so much for watching this video. If you like this video, and if you would like to support me to build more videos on emerging technologies and blockchain, I would love for you to press on the like button as well as the subscribe button, and looking forward to sharing more information. Keep watching out in this space for more interesting and exciting videos on technology.